Hello, this is going to be the video going over reflections. All right, what reflections are, how to do them, and just some stuff about reflections. A reflection is a type of rigid motion in which your pre-image is going to be flipped across a line, and we call that the line of reflection. The pre-image, is flipped across the line of reflection. So you may have done a reflection before, maybe in 8th grade, possibly. But basically what happens is every single point, all right, is going to flip across the line, all right, that we call the line of reflection. And the key is that each point in the image is going to be the same distance away from the line of reflection as your original points. So we'll do some examples, and I think it'll make a little bit more sense. Reflections really aren't that bad for most lines of reflection. Now, obviously, it could get complicated depending on what type of line of reflection we pick, but if it's just a normal horizontal or vertical line, then you can actually just count. So I'm going to show you an example here. All right, we're going to do one on the x-axis and one on the y-axis. So we're going to reflect this triangle. So the first example we're going to reflect this over the x-axis, all right? And the x-axis, if you remember, is this axis right here. So what you want to do is you want to look to see how far away your points are from that line of reflection. So A is one distance away. So when it reflects over, A prime is also going to be one distance away. So you're just counting how far away each point is from the line of reflection. B is also just 1 point away, so we're going to go 1 point down across the axis of symmetry, and that's going to be B prime. Now if we come up to C, all right, C is 5 points away, so C prime, that's going to be 5 points down. And once you've got your points, you can go ahead and connect your points, draw your lines, and make your shape. And so we can see that our triangle has been reflected. So it doesn't look the exact same. It's oriented differently, but it is a rigid motion, so your triangles should be congruent to each other. So that's the x-axis. We can do kind of the same thing with the y-axis. We're actually going to go A prime, B prime, C prime, and turn that into a double prime, B double prime, C double prime. So again, we can do the same thing. All right, this is our y-axis right here. So we want to see how far away all of our points are from that. And so again, we're just going to count. All right, A prime, that's 1 point away. So that's going to go to right here. We're going to call that a double prime. We've got C prime, that's 1 point away, so we're going to go one distance away on the other side. And then B is 5 away from the y-axis, so we're going to go 5 to the left. And there's B double prime. And again, we've got our triangle. Oop, that was not good. So that's how you do a reflection, okay? You're just going to kind of draw your line of reflection if you need, but you're going to be counting kind of how far away coordinates are. So we're going to look at some more examples. The one that's a little bit hard is or the line y equals x. Okay, the line y equals x is a diagonal line. So the diagonal line is the hardest one to do because it's not as easy as just counting. All right. So I'm going to kind of show you how to do this here. All right. When you're going across the line y equals x, what you're going to be doing is you're actually going to be flipping your coordinates. Okay. So they're straight up telling you in the equation that y equals x. So when you're doing your transformation, all right, xy is going to become yx, right? Y equals x now, x equals y. So the coordinates are actually going to flip, okay? And that's going to take you across the line. So if we look at our points, all right, G is at -4, 3. And so G prime then, we'd have to flip those, is going to be at 3, -4. Okay? And you can do this for all of your shapes. H, that's at -2, 5. So that's going to flip to 5, -2. E is at -4, 8. So that's going to flip to 8, -4. What is that? E. And then F is -7, 5. So that's going to flip to 5, -7. And if we connect our points and we kind of look at what we just drew, it should look pretty similar to the original shape, just reflected diagonally across that line. So you can kind of see, if you look at it like this, right, you can kind of see how it's been reflected. So this is the only one that's a little bit tricky, and you just need to remember this rule right here, okay? X and Y, they're just going to flip places. All the other ones you can count. So I actually want you guys to try these, okay? I want you to try them on your own. And then I'm going to pause this video, try it on your own, and then play the video and see if you did it correctly. So go ahead and give that a shot now. Okay, so hopefully you were able to complete those. I'm going to, kind of do this a little bit quickly since I already kind of went over in detail how to do them above. So this one, we're going across the y-axis. So C and A, those are both one coordinate away. So C prime and A prime are going to be one coordinate away. B prime, that's 3 to the left. So we're going to go 3 to the right. And there's B prime right there. And so this ends up being our triangle. Again, so D, E, F. This one's a little interesting. D, it's 2 up, so we're going to go 2 down, and we're going to make D prime. F, you'll notice, is actually on the x-axis, so its distance is 0. So F prime, is also going to be on the same point, right? So if it's actually on the line of reflection, it doesn't reflect. And E is 1 above, so E is going to flip to 1 below. So this is how the way that you can think about this, it's kind of like it's touching the mirror, right? If you touch the mirror, it appears like you're touching yourself. So the F and F prime, they actually end up touching each other, and it just kind of flips like that. This one says over the line x equals -1. That's just a vertical line going through -1, and this doesn't change anything, okay? Like I said, if it's straight horizontal or straight vertical, you can just count. Just instead of it going across the y-axis, now it's just moved over a little bit. So we're going to look at C. C is 1 to the left, so C prime is going to be 1 to the right. B is 1, 2, 3, 4 to the left, so we need to count 4 to the right. 1, 2, 3, 4. There's B prime. And A prime is also 4 to the left, so we're going to again count 4 to the right, and that's going to give us A prime. So that would be how you would do those 3 problems. We're going to finish up real quick, all right? Number 7, the vertices of a triangle are at 3, -1 for x. So let's plot these points. So that's 1, 2, 3, -1. So there's x. Then we've got -1, 8. That's y. And then we've got 6, 4 for z. The image of the triangle is reflected over the x-axis. All right. Forgot to make my triangle. That'll help us out a little bit. So it's reflected over the x-axis and then is translated 1 unit to the right. Provide the coordinates for the vertices of the final image of the triangle. So this one's actually interesting. So this is, again, we're doing 2 transformations here. We're reflecting over the x-axis and then translating 1 unit to the right. So you can do this all at once, or you can do it separately. Like you could do the reflection and then the translation, but I'm going to do it all at once. If we look here, so we've got x, that's 1 below. So it's going to reflect to 1 above. So normally it would be right there, but we're translating it 1 to the right. So it's going to end up here. Z is up 1, 2, 3. Z is up by 4, so Z prime is going to be down 4. And again, we need to go 1 to the right. And Y is up by 8, so Y needs to go down by 8 to Y prime. And again, we're going to the right by 1. And we can connect our points. And we see that it's been reflected and shifted. So this is actually called a glide reflection. I don't think you really need to know that, but just a fun fact. Last thing that we're going to talk about. So in this unit, we also kind of talk about symmetry. The way that it's connected is because it's kind of done with transformations. Transformations, shapes have what we call lines of symmetry. All right. And in order to have a line of symmetry, it means that if you reflected over that line, the shape wouldn't change. So these are all the lines of symmetry for a square. And if you look here, right, all the points of the square go to each other. So like this point would reflect to over there. This point would reflect to over here. This point would reflect here. This point would reflect here. And nothing would change. After you did the reflection, the square would look the exact same. So really all you have to do is just how many lines of symmetries exist. And there's some different ways to go about this. Sometimes there's 0. Sometimes there's a lot. This shape is interesting. We got 3 circles. And I'm going to say it looks like there might be 3. Okay. It just kind of takes some practice looking at it. If I draw one straight down, I believe that is a line of reflection. Basically, think about art class symmetry. Is it the exact same on both sides? And I believe it is here, I believe. So I think there's actually going to be 3 of these because I think that... Why can't I turn that? Okay. I think there's one that goes like that, and then there's one that goes like this. Yeah. So this one would have three lines of reflection inside of it. Let's look at this shape. This shape actually only has one. The reason it only has one is because, come on. Oh, it's not the same at the on top as bottom, so you can't go like horizontal, but it seems like it does have a line of symmetry going straight across, up and down. Kind of looks the same on both sides. This one actually seems like it has a lot. Circles have infinitely many lines of rotation, so if it looks like a circle, you're gonna get a lot. It seems like all of the lines of symmetry here are going through the gears, as long as it goes straight through. So there's a line of symmetry, there's a line of symmetry, here's a line of symmetry, and there's a line of symmetry. So for all of those lines, if you reflected over it, it'd be the same on both sides. Last but not least, because of the way this is colored with the red triangles, I actually think this has 0 lines of symmetry. I don't think there's anywhere you could draw this, because even if you drew straight up and down, I don't think this is going to work, because you've got like the tip of the triangle here, but over here the tip of the triangle is down, so like they're not the same. So this one I actually think is 0. So I forgot to write the numbers the whole time. How many did I draw on this one? 4. So this one has 4 lines of symmetry. This one has 3 lines of symmetry, and this one has 1 line of symmetry. So we'll get some more practice with this. It's just kind of weird, just kind of looking at it, and that's literally all you can do with it. But this is reflections. It's more important that you can do the actual transformations like on a graph. So go ahead and give the practice a shot. Actually, the practice will be done the day after you watch this video, unless you just want to do it back to back, which is fine. But if you have any questions, let me know, and have a great day.